Hello students, today in your geometry class, you're going to be working on finding the area of a regular polygon. Before we start, let's try working on these two quick practice problems. This would be a good time for you to pause your screen and solve these problems on your own. Hopefully you've paused your screen and you're now coming to check the answers. For number one, because it's a trapezoid, we use the formula for finding the area, which is 1/2 the height times the quantity base 1 plus base 2. Now, you'll notice that this is an isosceles trapezoid. Now, because this is an isosceles trapezoid, that means these lengths right here must be equivalent because they're an isosceles. So if the distance of your base 1, we're going to use the red line to mark that. If this distance right here is 5 because it matches the top base, then that must mean the ones in blue must be that difference. So that'll be 3, and this will be 3 because they should be the same. So we're looking at a 3, 4, 5 triangle. So we can calculate that we have 1/2 times the height, which is 4, times the quantity of the sum of the two bases, so 5 plus 11. So this gives us 1/2 of 4 is 2 times 16. The area is 32 square units. For number 2, we have a kite. The area of a kite is 1/2 d1 times d2. So that's 1/2 times the whole diagonal, which is 4, and the other diagonal is 6. So that gives us 2 times 6, which is obviously 12. So the area of this kite is 12 square units. So at the end of this lesson, you should be able to find the area of a polygon using the apothem. So using this inscribed pentagon, we're going to label our parts. Now the radius is the diagonals that connect from the center of our polygon to one of the vertices, the points where the two lines meet. The apothem is the height that starts from the center to one of the sides of the regular polygon. It bisects it and is a perpendicular bisector. Now, the way we find the area of these regular polygons is to do 1/2 ph, where p is the perimeter and h is the height, or rather the apothem. Now the only problem I have with that is that most people will forget that. Hopefully you've remembered that in every single shape it is composed of several triangles, and that's the way that we're going to approach it. If you'd like to use the formula, you're more than welcome to. However, I wouldn't recommend it. So to start, we're going to find the measure of angle 1, 2, and 3 just to do a quick reminder. Now, hopefully you can tell that there is a circle in the center where these things are being intersected. So here's our circle, and that's being split into, because it's a pentagon and we're creating 5 triangles and then we're cutting in half again to make right triangles, we have 10 different angles. So we're trying to find angle 1, which is this one. So in a circle there are 360 degrees. So 360 degrees divided by 10 equals 36 degrees. So from that we know that angle 1 equals 36 degrees. Now, we also know that because the apothem is a perpendicular bisector, that means this angle is 90 degrees. That means we can figure out that angle 2 is equal to 180 degrees minus 36 minus 90. Therefore, angle 2 is equal to 54 degrees. just a note, because it's a regular polygon, that means that angle 1 and angle 3 must be the same angle measure. Therefore, angle 3 is also 36 degrees. And that's going to help you later on this problem, but we're going to move on and actually find an area of a polygon. So, we're going to break this down a little bit more so you can see how this works. Now, in a regular polygon, we're going to create some triangles. So in this hexagon, there should theoretically be 6 triangles, like so. And keep in mind, these are all considered a radius because this could be inscribed in a circle. Now these lines in blue that we're creating are referred to as the apothem, or the height within each shape. And by doing this extra line for the apothem, instead of having 6 triangles, we actually have 12 because we're doubling each one up. Now, what we're going to do to make this slightly easier is we're literally going to take one of these triangles and work with one triangle only. So, we're going to recreate this bottom triangle right here. And we're going to create the apothem line, which we're going to do in blue. Now, we know that this base is 18 because it's a regular polygon. Remember, regular means all sides are the same. Now, to figure out this inside angle, you'll remember that there are now 12 angles involved. So we're going to take 360 and divide by 12. And we'll find out that this is a 30-degree angle here. This is a 60-degree angle because remember the blue dashed line creates a perpendicular angle. Now, if this whole length is 18, then this side right here must be just 9 because it's half of the whole triangle. Now, if you remember 30, 60, 90 triangles, this will be much easier. But because not all triangles work out so nicely, we're going to do it using sine, cosine, and tangent features. So, the important thing to find here is the apothem, which is our blue dashed line. So you can either use you could use tan, tan of 60 degrees equals x divided by, let's say y divided by 9, because it's opposite over adjacent. So we're going to multiply by 9 to both sides, and you will get y equals 9 times tan 60 degrees. And your answer will turn out to be y equals 15.88, or 15.588. So that would be your apothem. Okay, so to find the area of a triangle now, area of a triangle is equal to 1/2 base times the height. We know 1/2, we know our base. The base is 9, because we're doing it for the right triangle, and the height is 15.588. and that will give you 70.15 for the area of one right triangle. So 70.15 is the area of one right triangle. Now, notice I said one right triangle. Within this hexagon, there are actually 12 right triangles. Therefore, the area of the polygon, of the hexagon, equals 12 times 70.15, which is equal to 841.78. And that's the area for one regular hexagon. Now it's your turn. I want you to find the area of one right triangle for this regular pentagon, and problem 2 is to find the area of this pentagon. That's all for now. See you guys next time.